here are the two theorems we're talking about today. Side angle side. If you have two sides in the included angle of one triangle, and it's congruent to two sides in the included angle of another triangle, then you can say the triangles are congruent. So let's start with that one. We have two triangles here. We are using side angle side. So we've got SAS for both. The angle has to be between the two sides. So it's like sandwiched between them. That's what, when I say included angle, it means between the two. If the angle was on the other side of the two sides, then you would have ASS, which is inappropriate and it doesn't work. Okay? So it has to be in this order with the angle between them. BOW is congruent to, in our case, MAN. The other one we're talking about today is hypotenuse leg, which we can only use on right triangles. You have to have the hypotenuse of one and the leg of another. So if you forgot how right triangles work, so you've got your right angle, the side that's directly across from the right angle is called the hypotenuse. And then the two sides that touch the right angle are called legs. So when I say hypotenuse leg, I'm talking about those two sides. You have to have the hypotenuse of one and the leg of another. So in this picture, we have, here's the hypotenuse, here's the leg. It's congruent to the hypotenuse and the leg of the other triangle because these are right triangles. You can only do this when you have right triangles. So CAB is congruent to FDE. Because of hypotenuse leg. So just like yesterday, we're going to look at the pictures, we're going to decide if they're congruent and tell how, and we'll write a statement if they are. You're not always going to have everything marked, so sometimes you have to look for other things that might be congruent. Number 1. We have congruent sides already. We for sure need to get another side. Tell people you're sitting with. How can we get the other side? Or how do we get another? The one they share, you can count. So this one, woohoo, now we have side side. You have to get either an included angle or you have to get another side. You can't just be like, well, Miss Brent, the other side on the outside, those are congruent because they look congruent. No. But you do have parallel lines marked by those little triangles. So you can use alternate interior angles. These two angles. And it does have to be these two. It can't be the other ones because they have to be touching the transversal. 1 is congruent to 2. Because they're alternate interior angles. So you now have side, angle, side for both. Are they congruent? And if you don't see it, here's, sometimes it's helpful to like mark the letters. Yes, because of side, angle, side. And now you should say that triangle ABC is congruent to triangle what goes with A? C, well, a C, B corresponds to D, and then A to C. C, D, A. Okay, on this one, you already have a bunch of stuff marked congruent, so I would maybe write in little letters so you can see what order they're in. Okay. This is very inappropriate. It's not school appropriate. Do you have side, angle, side? No. Do you see how the angle is outside of the two sides? This is what does not work. Okay? Can't do this. It's inappropriate. And also, if you look at the triangles, when you have side, side, angle, or angle, side, side, the third side can be a different measurement. Doesn't work. No. You can remember it by remembering that it's inappropriate. Okay? So this doesn't work. The angle has to be between them. Logan, where's my other side?
AC and BD.
AC and BD. We had that. Can you get another one?
CD and AB.
CD, B. Can't get those congruent. I see what you're saying. I need a side that's already congruent between them.
Oh, the one.
Yeah, the shared one. Okay. The shared one's congruent. You have a right triangle. You have the hypotenuse and a leg for both. Are they congruent? Yeah, they're right triangles, and you can use HL. So you say that triangle ABC is congruent to triangle. What goes with A? D. D, C, B. Order matters. So either number them or like make a T-chart. FJ is congruent to HJ. And JG bisects angle FJH because it's all given. You're told that JG bisects FJH. So it's cutting the angle at the top into two parts. Angles 1 and 2. Ava, what can we say about those two angles? Yeah. These two are the same because it bisects. So in your proof, you can say, make sure you've labeled angle 1 and 2, by the way. You've got to label it. Otherwise, I don't know what you're talking about. You're like, angles 1 and 2, and then it's not actually in your picture. Write it in. Angle 1 is congruent to angle 2 because we had the definition of what kind of bisector? Angle. I'm shortening it by putting the angle sign. Okay. Definition of an angle bisector. Great. You have a side, you have an angle, you have to get another side. Kyle, where can I find another side that they have in common? This one. JG is the same. JG, oh man, I'm trying. JG is congruent to JG because it is reflexive. That was one of the freebies from the picture. If it's a shared side, we call it reflexive because it's congruent to itself. Now look at what you have and mark the letters if you need to. What are we going to use to prove they're congruent? Addie, Rush, what will we use?
Side, angle, side.
Side, angle, side. So make sure you take a line to say that they're congruent because of side, angle, side. SAS. So you have that these two lines, we talked about this yesterday, are cutting each other in half. We literally had a proof almost identical to this yesterday. They're bisecting each other. Emma, can you give me one pair of congruent sides? So close. These two sides, the blue line is cutting the red line in half. The red line is cutting the blue line in half because they bisect each other.
So AC and B.
Those can be congruent to each other. You're on the right track. We're using those two lines. Allison, what do you think? AE and CE. And John, what else? Yep, these two. Because they bisect each other, they're cutting both in half. So now write down the statements for that. AE is congruent to CE. And you can do it on the same line that BE is congruent to DE. Because of the definition of what kind of bisector this time? We're cutting in half angles or segments? Segments. Make sure you tell me, like be specific, because we're going to have both. You have to tell me if it's a segment or an angle that you're cutting in half. Almost done. You have two sides. You either have to get a third side, which you cannot do, by the way. You can't look at this and be like, well, those sides look like they're congruent, so definition of congruence, they are. No. You have to be told. Look at the picture. You can get a freebie from the picture. Abby Chambers, what could I get? Yeah, these two. Number them if you're going to use angles 1 and 2. So 1's congruent to 2 because of vertical angles. And in your proof, you can just say vertical angles is good enough for me. And you should have enough information now to say that the triangles are congruent. If you go to your picture and label the little letters, then you should know which one to use. We're going to use side angle side. Triangle ABE is congruent to triangle CDE because of side angle side. We have one more. You can write down your givens. Okay, if you look at your cheat sheet, if you're given that lines are perpendicular, which is what that symbol means, then what should you immediately say right after? So look at your gold sheet so you can tell me. What should I say, Justin?
No clue.
Look where it says perpendicular. If you're told that things are perpendicular, then what should you say right away? So because you have perpendicular lines, you can say you have right angles. We're going to label these two That one's reflexive, it's shared, so JG is congruent to JG. You have to tell me that. Because it's the shared one in the middle, reflexive, it's congruent to itself. You have right triangles. Double check. Make sure that you have HL. You do. So you can say the triangles are congruent because of hypotenuse leg. FGJ is congruent to triangle HGJ because of HL, hypotenuse leg.